X-ray tubes are at the heart of many of our medical devices that are essential for diagnostic imaging and interventional procedures. Here are some examples. In general radiography, X-ray tubes are used in stationary X-ray units, in fluoroscopy devices, mobile X-ray units or C-arms. They are also installed in CT scanners, mammography units and angiography systems. In all these devices, the X-ray tube is the primary source for generating the X-ray radiation that is essential for image creation. X-ray tubes differ significantly in their construction and appearance, depending on the medical device they are used in and their specific application. These differences arise, for example, in the focus spot size, and thus the image resolution, the tube voltage, the physical design itself, as well as in the anode construction and anode material. For example, we differentiate between stationary anode tubes, which have a fixed anode that does not move during operation and are used, for instance, in mobile X-ray units, and rotating anode tubes, which have anodes that rotate during operation to better dissipate heat. These are used, for example, in computed tomography or angiography. Despite all the differences, the basic structure of an X-ray tube is always the same. It always consists of three basic elements. First, the cathode. It is the negative pole and serves as a source for the electrons. Second, the anode. It is the positive pole and serves as a target for the accelerated electrons. And third, a vacuum enclosure that both are housed in. The vacuum is essential to prevent the electrons from colliding with air molecules on their way from the cathode to the anode. An X-ray tube is part of one or more external circuits that are necessary for its operation. The cathode typically consists of an emitter made of tungsten. By applying a heating current, the emitter is raised to a high temperature, leading to thermionic emission of electrons. The anode as a target is usually a combination of different metals and graphite. A very high electrical voltage is applied between the cathode and anode. This ensures that the negative electrons are accelerated extremely quickly towards the positively charged target. When the fast electrons collide with the target, they are abruptly decelerated. During the sudden deceleration, part of their kinetic energy is converted into X-rays. The X-rays generated leave the tube through a special window and can then be used for medical imaging, for example. Incidentally, most of the energy of the electrons is converted into heat, which is why X-ray tubes often must be cooled so they don't overheat. And that is roughly how an X-ray tube works. Very simplified.